Hey, welcome everybody and good morning. We are coming into this session of Databricks for Mortals, helping keep anger and frustration at bay. As in the first session, we heard that Fabric is the one product that everybody likes to talk about now, so I'm going to talk about Databricks and not Fabric in that case. So that's where we're going to start. So I've been working with Databricks in my projects in the past few years. And what I have noticed is that for the people who do not come from the data scientist, data engineer background, it can be a little intimidating because the premise of what is happening with my slides, well, the premise of Databricks is that we start from looking at notebooks. And I'm sorry, my slide change does not work. Okay, let's see if that works now. So the premise of Databricks is that you work with notebooks. That's the history of Databricks. That's where it started. There's now more options than that, but it can get quite a bit of a barrier for you if you're not used to working with notebooks. It can feel something strange. And the other thing is, of course, there's many components. So figuring out which parts do you actually need and how you use them. And then on the other hand, how do they fit together? That can be a bit of a difficult task to take on. So in this session, what we're going to be aiming to do is first we're going to look at an overview of Azure Databricks, the different components that are there, and then how they fit together. Then, of course, since we're talking from the context of Azure today, we'll look at how can you work with other Azure services when you work with Databricks and some of the most common use cases. Fabric will be mentioned as well in this case. And then lastly, we'll look at how do you make it a little bit easier for your users to get started with Azure Databricks, and how do you make it clear in terms of structures of data and finding your data. So we'll look at how to make it bring some clarity and sanity to the mix as well. So I'm Heini Ilmarinen. I come from Finland. It was very wintry there when I left yesterday, but here it's more like fall time again, so I'm a little weirded out. I work for a company called Polar Squad as a DevOps consultant. So for me as a data professional, that means working in data projects, looking at architecture, looking at DevOps practices, development practices, and things like that. I'm a data platform MVP and MCT, so I do run some trainings occasionally as well. And then I'm one of the hosts of Knee Deep in Tech podcast, where we do focus on a wide variety of Microsoft technologies and some data things as well. As mentioned, my personal favorite is architecture, just kind of that aspect of how do things fit together. I really like puzzles and things like that, so I kind of feel like I can solve puzzles as my work. It does feel that way. And yeah, my background is in mathematics. Yeah, if you want to talk math, you can always reach out. Nobody ever does. So I'm kind of, should I take that out? And as you've seen here, I process information by drawing little pictures in my notebooks. So I decided that's a good way to do my slides as well. So you'll see a bit of doodles here too. So let's get started. We're first going to talk about figuring out an overview of Azure Databricks and the different components that can be found there. So if we think about a user coming into Databricks, we first need a Databricks workspace that we create. Of course, for me, that is mostly in Azure, but it could be in AWS or GCP as well. The product is available in all of those places. But for the user coming in, they're most probably interested in either creating a notebook and working with their data or creating a SQL query to figure out something about their data. So those are probably the two options. But of course, those do not run on their own, but we need some kind of compute behind the scenes. And for Databricks, we have the Spark clusters that are available there with the Databricks runtime. Or on the other hand, we also have SQL warehouses that we are able to use. So you can see that there is maybe some like alignment here. The SQL warehouses we can of course only use for running SQL queries. Notebooks we can run on the Spark clusters, or on the other hand, if we have a notebook that just contains SQL queries, we could use a notebook to run it against a SQL warehouse as well. So that we can run on either platform, depending on what kind of code we have in there. And for notebooks, you can think of them as having both code blocks, as well as you can have commentary in there. What does this piece of code actually do? And then your notebook is run cell by cell on your cluster. And then, of course, once you've worked on your notebooks and your SQL queries, and you really think that, okay, this is doing something useful on my data. It's, for example, doing some cleaning of the data. It might be doing some aggregations and transforming the data in a more massive way. Then at that point, what becomes relevant is how do you schedule that? And within Databricks, we have something called workflows, and that is the side of Databricks that you can use for orchestrating the notebooks and the SQL queries that you have created. So essentially, you use those to run a specific notebook or run a few notebooks in a specific order. There is kind of two parts to the workflows. There is the more traditional side, which is the jobs. So where you create a job that defines which notebooks do you run in which order, what is the trigger, and so forth. But there is also a newer addition, which is Delta Live Tables. I've always found the name a little misleading, I could say. So with Delta Live Tables, you're able to define how does your data get updated, and then Databricks takes care of keeping the data up to date. So it is a kind of an approach where you give a little more responsibility to Databricks on keeping your tables up to date. So when we do then come to creating workflows, when we run our notebooks, we would use something called all-purpose compute. And that will then give you the interactive output. You are able to see, run display commands on your data frames and so forth. But then when you run workflows, there's not that same aspect that you are kind of like running cell by cell, but you want everything to run one after the other. So there's a very specific kind of cluster type called job clusters that you would typically run the workflows on instead. And then on the SQL warehouse, we also have some variations. They're not so much related to whether you run jobs or you just run ad hoc queries, but there is the more dedicated SQL warehouse option, where there is actually both this classic and pro version, but going forward, you should be going for the pro version. And then there is also a serverless option, which is available in just a few seconds for you when you run your query. So we can see right away there's quite a variety of compute options that you need to know when to use each of these. And you need always those so that you can run your notebooks and your SQL queries. And then you would schedule those with the workflows to have the automated processing in place that you might need. The one additional really important piece of Databricks is Unity Catalog. And even though it's quite a recent addition to Databricks, it has taken on quite a huge kind of part of the landscape and has a really important effect, and we need to plan it accordingly. So Unity Catalog is what came in to replace Hive Metastore. And Unity Catalog is, or Hive Metastore, is the Metastore layer that enables you to really build a lakehouse architecture. So with that, we are, of course, saving our files in storage as, for example, Parquet or Delta files. So in that sense, we need some kind of Metastore layer that is going to make sense of those flat files. And that is one portion of what is included in Unity Catalog. So it has the Metastore layer, but in addition, Unity Catalog also has access control in it. So you can do all your access control to that metastore layer that you have defined in your Unity catalog from there. But it also has lineage capabilities in it as well. And what has been the most recent trend is that anything new that comes to Databricks, you're required to use Unity catalog. Everything is maybe too extreme, but almost everything. So it's really good to get to know Unity catalog. If you are using Hive Metastore, there is ways to migrate to Unity catalog. So it's not a huge thing to do. All right. So quite many pieces. When we think about the organization of the workspace that you are using, if you start doing a lot of notebooks and SQL queries, it will start to get quite mixed up if you have no folder structure there. So there you can bring some organization by, for example, having team level folders where you can then have different topic areas and have your notebooks and SQL queries organized in those. There is also a repos option. So this enables you to bring the files that you have, for example, in your GitHub or Azure DevOps repository and bring them to the visual interface of Databricks. And then it has also the repo client side, so you can actually create a branch and then make your changes and sync them back to your repo provider. So for example, GitHub. So those are kind of the two ways that you can structure your files. There came now an update that you can have the repos within your folders, because those were like two separate areas and it could get a little confusing, like where are the main files? And if you have first worked on it from the folders section and then it's brought into your GitHub repo, then somebody goes in and edits it from the folders again. And of course, it's not then going into the GitHub again after that, since it's not in the repos section. All right, so that is the overview of everything. Well, not entirely everything that is in Databricks, but the main components that we need to be familiar with to get going. One other important aspect that we have to understand is that within Databricks, there is kind of two layers. There is the control plane, which, for example, includes the definitions of workflows, a lot of the metadata. It does not include like your data in your data lake or anything like that, but it includes a lot of the metadata layer of Databricks. And it also brings then all the scheduling for the clusters and so forth. So the control plane is something that is Databricks managed. You do not have control over it. You don't have like networking configurations you can do for it or anything like that. But then the compute layer is, because that is then what runs your queries and notebooks. That is what can be in your customer environment, and you can even configure it in your own virtual network. So in that way, you're able to ensure that, for example, your data doesn't go to some Databricks managed environment. And this layer, on the other hand, is called the data plane. What is a little bit of an odd bird out is the serverless SQL warehouse, because that is something that is hosted in a multi-tenant way. So Databricks then, of course, manages that. And that, of course, then has implications to, for example, if you need more secure networking, for Databricks, you can use VNet injection, and it would then enable you to have all your clusters and all your compute created in your own virtual network. But that will not happen to your serverless SQL warehouse because it is multi-tenant. So that will always be in Databricks managed virtual networks. And then, of course, if you have your data in a storage account, that brings implications to how you manage the firewall of that and so forth. So it's good to understand this differentiation of the control plane and then the data plane. All right, that brings us to the end of this overview section. And if you do have any questions at any point, feel free to put them into the chat. I have it somehow visible here, so I can pick up any questions that come along. So then, of course, the Second question is, how do we make Databricks work with other Azure services? And well, I'll start with the most obvious in the beginning. So I think for most people, if you think about working with Databricks, one of the most obvious things might be that, well, you have some data in your Azure Data Lake, and you would like to also in the future put all your data in an Azure Data Lake storage, and you want to read and write your data from there. Makes complete sense. So that is maybe the most obvious kind of integration even that you can do with Databricks. This has luckily become easier as time has gone on. There has been times when you've had to create service principals and then have a lot of code to pull in the service principal information, and then you can connect to your data lake, or you've had to mount the data lake into your compute or so forth. But again, with Unity Catalog, this has become much easier, and we'll look at that in practice, how that works in a little bit. But if you do kind of set up your Databricks to work with Azure Data Lake, then you can, of course, run your notebooks and SQL queries against the data that is there. If you're, for example, running a SQL query, you could use the serverless SQL warehouse to query data that is in the data lake and defined in your Unity Catalog metastore as a table. And then that way it's really easy to work on that data. And then, of course, if needed, you could create a workflow off of that to have the data updated as you go along. Other very common integrations that we might put in place is, the first one is using secrets. And for that, most commonly, we would use an Azure Key Vault. And within Azure Key Vault, then you can add any secrets that you have. You have your name of your secret and then the secret value. And then you create a secret scope within Azure Databricks that points to that Azure Key Vault. And that way, from your notebook, you are able to reference that secret scope, just like also a Databricks-backed secret scope as well. Something to consider here is that currently it is the control plane that makes a connection to Azure Key Vault. If you remember the previous slide where we have the control plane and data plane. So the control plane is something that Databricks manages. And so if the connection is made from there, again, we have implications, for example, for networking. So that's just good to keep in mind. Then the third most common integration that I've seen with Databricks is using Azure Data Factory or Synapse pipelines, or I guess from now on also Azure Data Factory within Fabric. And what you would do, even though there is the workflows within Databricks, is that quite commonly Azure Data Factory is used for the scheduling and for the data integration portion of having the pipelines in place. And so there is a activity in Data Factory directly that you can use to run a notebook from Databricks Workspace. But another approach that you could use is there is actually an API for the jobs. So within the workflows, you have the job category. So there is an API that you can use to trigger those jobs that are defined there. And what would determine whether you use workflows or Data Factory? If we think about workflows, that is something that works mostly within Azure Databricks. So of course, your notebook can, for example, fetch data from outside Databricks. It could call an API and fetch data in, but essentially the workflows can be used to schedule things within Databricks. It doesn't have like a huge set of connectors that Data Factory has. So it depends how are you using that. If you need a tool that can integrate with many different services and has a lot of connectors and so forth, then Workflows doesn't have that. Then you might want to use Azure Data Factory. But of course, the workflow side in Databricks is something that works very well within Databricks, but it is contained to the Databricks space. So that's why there is actually this need for sometimes to use this integration, that you are able to also use other tools than only Databricks and connect to other data sources, for example, in an easier way. And then we of course have another newer service that we might need to integrate with, and that's where Fabric comes in. So of course, I think now the question stands, like, Databricks has been around for a long time and it is a very mature product. There's not things that, like the basic things that have been around just work. There's nothing weird you need to do to them. But now with Fabric, people are trying to figure out, well, can you make these two services actually work together and kind of make each other better, in a sense. So there is two ways that you could work with data across Fabric and Databricks, and there's probably some more as well, depending on your scenario. But some of the common ones that I've had discussions about is that within Fabric, there is the one lake for all your data. So one option that you could consider is that you could use your Databricks and all the data you have there, and then have some kind of notebooks in place that write data to one lake. And then that is available, for example, for users to create reports on, or even do continuous exploration and then figure out new solutions based off of that data. Because to be honest, Fabric is maybe a more user-friendly interface for at least some more business level users than Databricks is. The other approach that you could take, if you have a lot of data in your Azure Data Lake that you have created with Databricks already, and you want to still keep using that, you could have a shortcut to your Azure Data Lake storage, and then you could use the Fabric tooling to work off of that data and do whatever you want to do after that. I think with any kind of these integrations, whether it's Fabric or it's Azure Data Factory, what you need to consider is what are you using each tool for, and that you have a clear idea about that, so that you don't get into this place where people are using different tooling for the same things, and then your data ends up scattered, some in Databricks and some in Fabric, and you have no way to tell which parts are where. So just be clear on what are you going to do with each tool. So we won't go deeper into how you set up these different integrations up with today, but of course, if you have some specific questions, we can go into those in detail. All right. So Databricks does definitely fit in with the different data services in Azure, and it can be used in with Azure Data Factory as well as Fabric. And then, of course, there is the supporting services like Azure Key Vault that we might need to use as well in our solution. So now we get to the main portion of this presentation. So figuring out how to make this all make sense and have some structure and clarity in place. And that's where we will spend most of the part for going forward from here. So I think there's two aspects to ensuring that you actually have some clarity and sanity in your Databricks environment. One part is, of course, having clear guidance and like practices in place. As was already said about kind of using Databricks with other Azure services, it's good to know what you do with each service. It is the same within Databricks. You need to decide how do you use each part. So for example, decide on development practices. Do you have users develop their notebooks within the folder sections of Databricks, or are they going to use the repos integration and do development through branches and so forth? For more serious things, like things you want to take into production, yes, you should definitely get your code to be stored in Git and repos in some way. But for example, the exploration could be done within the folders, but then decide how do you like transition from an explorational notebook to one that is in production use. Then think about how is sharing allowed? Is it allowed just, there's some capabilities within Databricks where you can just click share and type a name and so forth. Is that allowed? Are there some restrictions? What are the access patterns for data? Is your data very open and can be viewed by anyone, or do you have to have more restricted approach to that? So that all, of course, depends on your environment specifically. And there's many things that are more about people and processes like this, but I will today focus mainly on the structures and how to make that support you and everybody who's working in your environment. So I already mentioned Unity Catalog, and that is kind of the hero in how to make the structures clear within Databricks. As said, Unity Catalog is really for that metastore layer on top of your storage that makes all your data make sense. And it is what allows you to have also organizational structures in place as well. So when we create a Databricks workspace and we start to think like, oh yeah, we want to have Unity Catalog enabled, where the metastore layer, the highest level of Unity Catalog is actually created is at the Databricks account level, which is something that you, even if you've been working with Databricks for a long time, you might not have realized there's an account level. It was actually made kind of visible quite recently. And the account level is really your organization tenant level. And Unity Catalog gets managed at that level. So within your account, you could actually have multiple Databricks workspaces if you're in your organization tenant. You are using Databricks in different teams and they all have their different workspaces that they use. So the highest level, like the top level of a Unity Catalog is a metastore. And a metastore is something that you create at the account level. And you can only have one metastore per region per tenant. So if you are one organization and you mainly work in Europe and your main location is, for example, West Europe, you can only have one metastore. So that's something really important that you need to take into consideration. That means that this is very much like an organization level structure, and you should think about Unity Catalog structures from the organization level. The next level that you have is a catalog level, and this will all make sense a little better once we go and look at this in practice. But then you would split that metastore into different catalogs. And since the metastore is just one metastore per organization, per location, that could mean that in the catalog level, you need to split between environments, between business units, between application teams. You need to think about what is the correct organization according to your organization and how you work as an organization. Then after the catalog level, we have schemas. And then as the last level under the schemas, we have tables. And then once you have this structure in place, then you are able to reference, for example, a table with this three-level notation. So you give the catalog name, .schema name, .table name. And then you are able to, for example, run SQL queries based on that three-dot notation. So since we have essentially three levels that we can really have control over, that's not very many at an organization level. So as an organization, you might have many catalogs that you create, and you might have the same set of catalogs, for example, for your test environment and your production environment. And then within each catalog, you would then have the schemas and tables and so forth. Since the Unity Catalog is an account level structure, it does not automatically get linked to a workspace, but after you've created a Unity Catalog, you can add workspaces to it. So you have to link which workspaces use this, and once you do have then Unity Catalog linked with the workspace, then unless you have access controls in place, then the entire structure of that Unity catalog is visible to your workspace. Luckily, there's been an addition to the capabilities that you are able to link a catalog or like limit which workspaces a catalog can be used from. So, for example, if you have a catalogs for test environment, you could link them to your test workspace so that they are not visible from your production environment, and somebody doesn't actually, by mistake, take some test data and then write the results into the production environment. So Unity catalog is an organization level structure, and we need to think about the structures from that perspective. So when we create a Metastore, you need an Azure Data Lake on the Azure side of the universe. So you need to have an Azure Data Lake that you set as the default location for the Metastore. And then you need an identity, which is created by creating an access connector or Databricks access connector resource in Azure. And essentially that's like a wrapper that then includes a reference to a managed identity. And you can have either a user assigned managed identity or a system assigned managed identity. So when it's a system assigned, then Azure will take care of the lifecycle of the identity, and you don't have to manage service principals or anything like that. So then, of course, when you have your access connector, you need to add access to that data lake, to that default data lake that you are linking with your Metastore for that identity to be able to write some data in there. So that's kind of an addition that you need. But you might start to see a little problem here, because we just said that the Metastore is an organization level thing. You can just have one per organization per region. So do you want all your data in one data lake? You might, but you might not, especially if you're a bigger organization. It becomes maybe a little bit of a security issue and so forth. So you don't necessarily want to actually use this default location. So then we need to figure out, what do we do then? When you do use the default location and then you write data to your Unity catalog, it will create something called managed tables. So that means that then Databricks will completely manage the lifecycle of tables. And when you, for example, drop a table in Unity catalog, it will also delete all the data in the data lake. So that might not also be something that you want to do if you have some data coming in. But there is an option to use also external tables. And this is where you would then have a separate Azure data lake, even maybe two different data lakes, one for test, one for prod, and your containers there, for example, your different areas, raw, clean, enriched, whatever you want to call them. And we're not going to go into the details of how many you want to have today. But anyways, whatever structure you have decided within your organization. And with external tables, then you can say that your table is here in the raw container within a service one directory. And you can kind of very specifically say this is where the data for your table is. For managed tables, you can actually use the default location, or you could also use an external location. So you could have Databricks manage the entire table, but just point to it, hey, go to my clean container and folder one in there and manage the tables within there, and you're good to go. So that would be also one option. I have personally always opted for external tables because when you use managed tables, Databricks then creates lovely GUIDs to the different folder structures. So if you have any need of leveraging the data directly from Azure Data Lake by other tools, it's really, you would need to create some kind of script to figure out which folder you need and so forth. The other aspect is, do you want to have that capability of, if you drop a table in your Unity catalog, do you want the files to disappear as well, or do you actually want the files and data be persisted, even if the Unity catalog structures get dropped? So that's kind of what you need to consider there. So far we've been doing a lot of theory, and it's a little bit of many moving pieces. So now we're gonna move into checking things in practice, because then it will allow for the pieces to fit into place. So we're gonna hop over to Databricks at this point. And here I have created a Databricks workspace in Azure, and I have that open over here. And then actually, if you go into your account and you select Manage Account, it will open the account console for you. So this is where you come to create your catalog. So if I go to my metadata tab here, I have already created a metastore here. So I have a metastore that points to a storage account in my Azure environment. So you can see the path there. And then, as said, the workspaces don't get linked automatically. So I have also added my workspace in there as well. Lovely, my portal has closed in between, so I'll just click that so it will get into the right place. So you can see I have the metastore there. I have a separate resource group for my Unity catalog default storage account, and then the access connector that was used. So if you look at the access control connector, that is, as said, kind of a wrapper that then includes the reference to your system assigned or user assigned managed identity. And for this, I have, for example, added a role assignment both to my default Unity catalog location, as well than the specific storage account I will be using today that is separate from the default location. All right. So we're going to start working with our data a little bit now. What you will see in the Databricks portal is kind of the main areas that we went through. You can see them here in the very top part. So the workspace contains all your notebooks and SQL queries, and if you save them. So as said, there is kind of this folder portion that by default has a user section where everybody has their own folder, and then a shared section, but you can create your own folder structures, for example, according to your teams and so forth. And then in the repos, you can link your external Git repositories or so forth that you might want to leverage. And then people can use the Databricks user interface to work on their notebooks and then get their changes into their branches as well. So that's that part. Within here, I have my own user folder, and I have created one amazing notebook. I have my storage location here. This is, as mentioned, a separate storage account that I have here with my Azure Databricks workspace. And if I look at my Azure Data Lake structure, I have these different containers that are created here. And then I have one folder that has my amazing squirrel data, because I thought squirrels are kind of fun. So there is a data set you can find on the internet that has some observation data about squirrels. So I thought that's very fun and useful. So, so first of all, I might have had, for example, that data dumped in my data lake, and I just want to figure out, well, what kind of data is there? So I can specify my file location and file type, and then I can read that file into a data frame. And if I want to kind of check what is actually in that data frame, I can add a display command and check, okay, lovely. I don't have column names in this data set, but it was possible to fetch the information. So we can then maybe put that into a little bit of a better better state, but we have some like latitude and longitudinal information where that where that squirrel has been observed. There's some open notes as how it interacts with people, what kind of things is it doing, eating, digging something, you know, the kind of things that squirrels do. And of course, information on what part and what kind of color they are and so forth. So really interesting data set, I would say. So I have already actually run these commands, but I'm creating some structures into my Unity catalog here. So I'm creating raw, clean, and enriched catalogs, and then within each of them, I am creating a schema that is called squirrels. In this case, makes complete sense. So I could have all my different squirrel tables within that one squirrels schema. So if I go into the catalog portion, I can see that I have this raw, clean, and enriched catalogs here. There is some kind of catalogs that show up by default. So there's a system catalog that is needed. There's also this samples catalog that you can use to get started and understand how Unity catalog works. And then you can see kind of the old Hive metastore in here as well. So you can do some restricting so that you don't have the unnecessary things visible for users. So that can be helpful. So I have just created these catalogs, and each of them always has a default schema and then an information schema. And then now there is also this squirrels schema that I added that doesn't yet have any tables because I haven't created any. But you can kind of think of schemas as maybe corresponding to tables or kind of like logical data areas. So for example, in the raw area, since it is mostly like the ingestion of data coming in, you might have your schemas per source system, for example, and then have the source system specific tables within that schema. But then, for example, in the enriched end of your catalog, you might want to have your data structured based on maybe data domains or more like the end result perspective. So you can take that into consideration when you plan the structures. But anyways, we've checked out our data. It's amazing. We've created some catalogs and schemas in there. Oh, that's where my display cell was in. I'll just take that out. I can just, if I'm happy, oh, it's raw data, we want it to be as it is, I can just create a table based on that file in my raw area of my data lake. So you create a table, when you add the location information, then it will create it as an external table for you. So that will already kind of do that automatically. So if I now go into my catalog in my raw area, I can see my amazing observations table that has great column names, as you can see. And then I could check at the sample data. Oops, it's a bug. Well, we'll see. I've had this happen occasionally before, and I've still been able to query the data. So, oh, this is the old results, but anyways, I'll get the SQL warehouse started while we go on here. So I'm going to trust that the data is actually still there, even though it gave me a little error on the user interface. If I want to read that table, I could use SQL just as part of my Python code by setting this spark.sql, and then in my SQL code, it's quite convenient. So I could just check what kind of data is there. So clearly it is in the table, even though the Unity catalog had a bit of issue there displaying it in the sample data. So I can see I can actually read it. The data is there. I got a little worried there for a moment. Another option, if you want to read that raw table that you have in place, is that you could change one of your cells to run SQL. So then you have this magic command here. You can change it here by the drop down. It will then remove that or put that in there for you. So I can also run that SQL and where is it? There. So it will then show me the results right there. And I can actually see that when you run one of these SQL queries within your notebook, it will put it into a data frame with the name _SQLDF. So that will allow you then to go into the next cell and start working on your data frame. So we'll just do that. So I'm gonna just, for my clean area, I'm gonna decide that I just want some of those columns from this table. And I've checked the mapping, so I'm gonna pick up an area name, part name, squirrel ID, and the activities it is doing. So just a very simple select statement. So if I run that, let's just leave that out of there for a moment. Let's just check the data. So now it of course looks much nicer. We just have the columns that we need, and we have nice column names there as well. If you want to have your data frame that you have created and done all your amazing transformations on, and you just now want to save that as table, you can then reference, for example, the clean area with that 3-level syntax of your metastore again, and say save as table. And it will create a table in that clean area based on the data frame that you are working on. So we will see that in a moment. So again, shows that since I had the display command there, but if I come into my clean catalog here and check my squirrel schema, I have this amazing observations table here and some nice sample data. That again works. Nice, thank you. That helps. So this is what it normally looks for you when you click into the sample data. It shows you some of the data there, so you're able to see at a glance what does it contain and so forth. So it's actually quite easy to work with a notebook and then write and persist changes to the catalog, which is really nice. And then of course, if I wanted to do some further transformations, let's like group by the park name and just see how many squirrels have been in each park. And again, I can save that as my final table that I want to have. Just again calling that save as table and then the 3-level reference. So I have this really nice data frame that will be then persisted again here in the enriched area. So if I check here, part name count, yes, exactly, that's what I wanted. And it's really nicely there. And then, of course, even within the Databricks notebooks, you can do simple visualizations on the data if that is needed. All right, so from within notebooks, it's easy to kind of interact with the Unity catalog and reference the tables. Once you've saved your data there, it's really easy to read that data as we saw, for example, here. So we can just reference that 3-level syntax and query that either from SQL or even from using Python or Scala as well. The nice thing about how Unity Catalog makes life easier for also maybe people who are not so familiar with notebooks and so forth is the fact that you can also come in here into the Unity Catalog, look at all your organizational data, go into the different schemas and figure out what kind of data you need. And then off of that, you can click the Create Query button there, and you get, a very simple SQL syntax there. And now you can see I'm in the SQL editor, and I actually am running everything against a SQL warehouse this time, a serverless one. So I can just run my query against that table and see what's there. And then I could go further to doing something else with this data, bringing maybe another table, doing some joins and going from there. But I think this is something that makes the use of Databricks much easier for many people, where you have this easy kind of, you can go into the data in the catalog and then you can easily create a SQL query based on that and go from there. You do have like this little catalog portion here in the SQL editor as well. So if you're like, oh, that was a completely wrong table, I actually wanted to look, no, I wanted to look at the raw data itself. Let's say that I can just take that almost went as intended, the other table of reference, and then see, okay, this was our original data, and then go, oh, we need another column, and go from there, for example. So a really easy way to interact with the data that we have defined in our catalog. But we see how the Unity catalog takes quite a central role when working with Databricks, and having good structures there will either, well, having good or bad structures there will make your life either easy or it will make it a little harder. So I would say it's good to use some time to really define how do you want these structures to be in there. Loving the chat. How does one become a full-time squirrel observer? That is the question of the day.
And which data?
Yes. Yes, these are the important questions in life. I agree very much. Welcome. Thank you. All right. So we've looked here how to interact with your data with notebooks. We've looked at how to look at your data in the catalog and run a query based off of that. But one more thing that I want to point out. In the very beginning of this, I just referenced my file location and was like, okay, I'm just going to read that. You actually need to have something in place so that you can do that so easily. So I had my storage account and I had access to that access connector there. So here within the catalog, you have also this portion about storage credentials and external locations. So the managed identity, the access connector that I had there in the Azure side, that has been added automatically here when I created the metastore for my Unity catalog. So I can see the storage credential here. And then I have created an external location for the raw area. So if I look at the URL that is included in there, so if I reference anything within this, like another folder in here, it will use the external location reference here that uses the credential. And as long as I have rights to use this external location, then I'd be able to read the data there. So again, the access control moves to Unity catalog as well, and you should kind of ensure that you define that correctly. But all you need to create other external locations is the credential and then the path to where you want that pointer to be. So we could have then pointers toward clean and enriched areas here as well. So that is why it was so easy to read the data in my notebook. One last thing that I almost forgot to say while I was here. So if I come to my squirrel table here in the enriched area, one of the nice capabilities of Databricks is the lineage. So within Unity catalog, there is this lineage section as well, which really nicely shows the connections between the different areas. So it always tries to kind of show the simple version, but then you can always expand. Now I realize I actually did this a little weird, because normally I would probably read the clean table and then create the enriched table based off of that. So not off of the raw directly. So here I now can see that, oh, I made a mistake as well. But the lineage works really nicely because you can also like see the lineage of a specific column. So I can see, oh, the park name came from column C2. And especially if you have a lot of tables that relate to each other, it makes it really nice to track down where did that come from? But the same as with the workflows, this does work only within Databricks. So this is not the kind of lineage tool that, for example, we heard about in the previous session about Purview, where you are able to connect to different data storage systems. This is just for within Databricks. And time is running so fast. Yes, exactly. So now as we've looked into the Unity catalog side, just to wrap up what we did, I had the Metastore created, and to create that, I needed the access connector and a default Azure Data Lake location. Within the Metastore, then you have the catalogs. This time I had the raw, clean, and enriched, but you would probably have like raw test, raw prod, raw QA, potentially, depending on how many environments you have. And then within the catalogs, you would have the schemas. This time I had the squirrel schema there. As said, in the raw area, you would probably consider like per source system, and in the more enriched side, you would probably consider more from the perspective of how is your data structured for the consumers. You are able to specify the location of where your data gets stored, either at the catalog or schema level. But if you do that, it will still be a managed table, even though it might be in an external location from the default that is there on the left. But then when you create the table, if you specify the location as we did when we created the table off of the CSV, and you say point there, then it will be actually an external table where it will use that data from a specific folder. So that's kind of what we went through. And to get all this working so that we are able to work with external locations, you need the storage credentials. This time we use the same access connector that we had for the Metastore, and then you specify the external location based off of that. All right. So in this very fast hour, I think it was a little shorter in my opinion, we went through an overview of Azure Databricks. What are the different components? Which parts do you work with just to get going with notebooks and queries? Then we checked in the most common ways that you would integrate with different services in Azure. So of course, for the first thing, Azure Data Lake, the most common one that you would work with. And then we looked at Key Vault and Azure Data Factory, and very shortly on Fabric as well. And then we looked lastly at how do you actually make the structure so that it is easy for you to find your data, and their Unity catalog is very much in the center and something that you need to take some time to plan out in a way that works for your whole organization. As said, it is very much an organizational structure, not just a single team structure. So thank you so much for joining. If you have any questions, I don't think I have time to answer them now since time is out, but I can, if you do have any questions, I can write them in the chat. I'll be still on the call later, or you can reach out to me on LinkedIn or Twitter X. and yeah, we can connect, and if you have any questions, you can reach out. And please fill in some feedback and let me know if there's something I should change or if something was good. I'm very much looking to improve this session further as well. So thank you, everyone.